Okay, so today I want to summarize everything about the series. We learned the Taylor series and Maclaurin series. So now I want to take you back into the pre-calculus day. So we learned this one geometric series is the sum of number a times r raised power n minus 1. R here is the common ratio and a is the constant. Okay, so the n from 1 to infinity, so I put n equal 1 right here, so I get r to the 0 equal 1, so I have only a, no r. So now n equal 2, you take the first term, you multiply by r, common ratio, you get ar. And the third term, you multiply another r, you get r squared. Okay, therefore the n term r raised power n minus 1, because the first term no r. So that is a geometric series. Now we beginning of the series here, we introduce the power series. So now look the same, right? So look the same, different, instead of r and this one different from that one. So how different it is? First of all, let me expand this one. We put 0 here, we have c sub naught. I put 0 here, x to the 0 equal 1, so no x right here. Then x n equal 2, so n equal 1, so I put 1 here and 1 here and have c1, x1 and c2, x squared, c3, x cubed. So this one we call the power series because 8 of him here, let me emphasize this one, 8 of this one here is the power. 8 of them in the circle is power. Power is something like x to the n, so this one we call the power. And r here is a constant, that's the major difference. The second difference is n here is represent the term, the order of the term. N equal 1, we talk about first term. N equal 2, we talk about second term. N equal r minus 1, we talk about the nth term. So n is about the term. However, here n represented by the degree. So n equal 0, we have 0 degree. N equal 1, we get first degree. N equal 2, we get second degree. Okay, that's three things different. Now, another different thing is this a here doesn't change, but this coefficient here changing. Okay, so depend on what? Depend on function. Okay, we introduce this one here. Now the question here: can we write a function as the series? Oh, I remember we can write function as series like this. You have 1 over 1 minus x had to be 1 plus x squared plus x cubed plus x to the 4 plus. So condition here, x have to be less than 1. So the same thing here, that from this one exactly the same with the geometric series. In this case, the sum equal a over 1 minus r. The sum, if r is less than 1, between -1 and 1. So the condition is r is have to be less than 1. So you look familiar, right? 1 minus x, a over 1 minus r. Can you see that? So a here is 1 in this case, and r here is x in this case. Just very the same, but we have to derive this formula in the future. Okay? So because I see this one so close to that one, so I remind you that this one here, given the function f of x equal 1 over 1 minus, we can write as a series. You can see that. What does that mean? If you put 0.5 right here, you put 0.5 here, 0.5, all to infinity, they will be the same. Okay, that's what the meaning. Now we try to discover this. Well, we can write any function we learned so far as a series. So let's take any function. Let's put any f of x. We can write into c sub naught plus c1 x1 plus c2 x squared plus c3 x cubed plus c4 x to the 4th plus c5 x to the 5th plus and so on. Okay? So now we try to write the function in terms of x. So, okay, the function in terms of the series, a power series. Not this series, but a power series. So let's start like this. So if I take f of 0, what happens? 0, 0, 0, always gone. So therefore f of 0 have to be equals C sub naught, right? Because I put 0 here, f of 0 C sub naught. So therefore I substitute C sub naught at f of 0, whatever f is, sine, cosine, tangent. Okay, so I have the first substitution here. Okay, plus now I fill out C1 in terms of f of x. So remember, this one never changed. All functions share the same of the power here. Share this, doesn't make any difference. They're all the same. But this one, x function different, the coefficient is different. So I start again. Now I want to find C1. What I mean by C1? I take f prime of x, so I take from here. Derivative of this one constant equals 0. So f prime of x equals C1. Plus, then I take 2 times C2, 2 times C2, x to the first power, and 3 times C3, 3 times C3 to the x to the square, here 3 times the x square, plus 4 times C4 x cubed, plus 5 times C5, 5 times C5 x to the power, and so on. Now I plug 0 again, so f prime of 0 equal what? Go, only equal C1. Therefore I substitute C1 equal f prime 0, I substitute equal f prime 0 and C1 right there. And my x still stay here. Now we continue to find C2. Okay, so now I take derivative again. Second derivative, f second derivative of x. So equal derivative of the constant equals 0. Derivative of this one time x equals 2C2 plus 3 times 2, 3 times 2, C3 x to the first power. Now I don't multiply them because I want to see the pattern. Okay. Then this one here is 4 times 3, 4 times 3, C4 x squared plus 5 times 4, C5 x cubed plus and so on. Okay. Now we do f second prime of 0. F second prime of 0 equal what? Put 0 here, gone. Then you have 2C2 left. Therefore, C2 equal f second prime 0 divided by 2. Okay, now I substitute this one into C2. So we're going to have f second prime 0 over 2 times x squared. So now the x squared stays the same here, okay? Not changing, okay? X squared. Okay, so now I try to do 1 or 2 more, then I see but the pattern, okay? So now you write this. Take third derivative, okay? F third derivative of x. Derivative of this constant equals 0. Derivative of this one equals 3 times 2 C3. Derivative of this one equals 4 times 3 times 2 C4. X to the first power plus 5 times 4 times 3 C5 x to the square and so on so forth. Now I put 0 in here. Third derivative of 0 equal, I put 0 in here, gone, put 0 in here, gone, and I'm going to have 3 times 2 C3. Therefore, C3 equal f third power 0 divided by 3 factorial. You see the pattern here, this is going to be factorial. So then I substitute here, I put plus f third power of 0 divided by 3 factorial and become x to the square. Okay, become x to the square. X to the square. X square. Okay, then one more. Okay, one more. So I take fourth derivative. So f to the fourth derivative of x equal derivative of this one equals 0. Derivative of this one equals 4 times 3 times 2 C4. Okay, this one gone. And plus 5 times 4 times 3 times 2 C5 x. So plus and so on. So now I solve for C4 because I want to substitute for C4 right here. I want to find C4, right? So then I divide by this. So f Okay, so now I continue to want to find out what is C4 in terms of F. Okay, so from here I take derivative, fourth derivative, this one gone equals 0. Fourth derivative equals 4 times 3 times 2 C4 right here, and 5 times 4 times 2 times 2 C5H. So therefore C4 have to be F fourth derivative of 0. Okay, divide by 4 factorial. Okay, when I put 0 here, all go. So equal 4 times 3 times 2. Okay, so then I substitute this one into here. So again, f of fourth derivative of 0 divided by 4 factorial set to the fourth. Okay, so now we can see clearly, we see the pattern, right? The first derivative over 1 factorial, the second derivative over 2 factorial, the third derivative over third factorial, and the fourth derivative over 4 factorial. In general, if you keep doing this and you have f n derivative of 0, I to the n power over n factorial, that is the n power term. That is n minus 1 term. Okay? So that in general like that. Now we have the formula, right? F equals this, right? So I try to do two applications. I try to do sine and e to the I to see what happens. Okay. So I give f of I equals sine of I. Okay, sine of I. Okay. So equal. So here I have to have sine of 0, right? So f of 0 is sine of 0. So f prime sine equals cosine, right? Cosine of 0. I plus f second prime 0 derivative of sine equal cosine derivative of cosine equal minus sine f0. Okay, I square. Then plus derivative of minus sine equal minus cosine. Cosine of 0. I to the third power. Okay, first power here f prime equal cosine equal the function is sine. So next one, derivative of minus cosine combined to sine of 0. Okay, I to the fourth power and derivative of sine again equal cosine. So cosine of 0 times I to the fifth power 2, 3. Okay, derivative of okay, first of all sine of 0, f of 0, sine of 0, f prime equal cosine of 0. So second derivative cosine equal minus sine of 0, and then derivative minus sine equal minus cosine of 0 I cube, and derivative of cosine again equal sine, minus cosine equal sine, and derivative sine equal cosine again. Okay, so now what is sine of 0? Sine of 0 equals 0. Okay, what is cosine of 0? Cosine of 0 equals 1. So this one you have 1x, and you have minus sine of 0 equals 0 again, or 0x squared. Cosine of 0 equals 1 again, and you have minus 1x cubed. And sine of 0 equals 0 again, right? X to the fourth, and cosine of 0 equals 1. So you have 1 x to the fifth power, this one equals 1. So you see that? So sine x equals x minus x cubed plus x to the fifth power, and so on, minus x to the 7 plus x to the sixth power. Okay? So now that is f prime, but you have to put 2 beneath the f second prime and 1 beneath the f prime. So x over 1 x cubed over 3 factorial. And to the fifth power somewhere here, you have to over 5 factorial and 7 factorial. Okay? And plus, x to the 9 power over 9 factorial. So that is a sine function. What does that mean? Sine of x equal that. That means you put any number here to the left, you put number to the right, they will be equal if you take to the infinity. Okay, we will take a look at that later on. Okay, you use calculator, you put 0.1 here, you put 0.1 here, 0.1 here, you get into like x to the 11, 13 or something, and you see super close, this is very close to each other. And we're going to use the row, we use the software to wrap, to wrap sine, right? You wrap sine function and you wrap the first three of them, you look like the graph marching to side from here to here, and you add some more, the graph march more and more and more. Okay, so we're going to do that. Okay, next. Okay, so now another one. Let's write equation, function e to x in terms of the series. Okay, so now, okay, f of x e to the x, so f of 0 equal e to the 0, which is equal 1, right? E equals 0 to 1. Now f prime 0, also f prime equal e to x, f prime 0 equal 1 again, we have 1, right? And this one 1 again because the derivative of e to x keep equal e to x, then you put 0 in there, so you got e to 1 and you have 1 again, this one for 1 again, x squared, but don't forget to put 2 underneath this one also 1, so you get x squared e cubed over x cubed over 3 factorial, and you put this one also equal 1, x to the 4th over 4 factorial, and so on. So this one e to the x equal 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Okay.